In this video, we will discuss solving quadratic equations by completing the square or using the quadratic formula. Not all complete quadratic equations can be solved by factoring. One procedure for solving these equations is called completing the square. This method manipulates an equation to get a perfect square trinomial that factors into the square of a binomial. Here again is the relationship between a perfect square trinomial and the square of a binomial. A squared plus 2ab plus b squared equals a plus b squared. To solve a quadratic equation by completing the square, I'm going to do a step on the left, and on the right, I will give an example. First, we write the equation in the form ax squared plus bx equals negative c. That is, we isolate the terms with variable factors. Then we divide the equation by a so that the coefficient of x squared is 1. So that takes us from ax squared plus bx equals negative c to x squared plus b over a times x equals negative c divided by a. Third, we form a perfect square trinomial on the left by adding b squared over 4a squared to both sides of the equation. So x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. Next, we factor the perfect square trinomial into the square of a binomial. That is, x plus b over 2a quantity squared equals negative c divided by a plus b squared divided by 4a squared. Now we take the square root of both sides of the equation. X plus b over 2a equals plus or minus square root of negative c divided by a plus b squared over 4a squared. Now we rearrange the terms under the radical. X plus b divided by 2a equals plus or minus square root of b squared over 4a squared minus c over a. We make equivalent fractions using the common denominator for terms under the radical. So x plus b over 2a equals plus or minus the square root of b over 4a squared minus 4ac over 4a squared. We write the terms under the radical as one fraction. X plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. And then we solve for x. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. For example, solve x squared minus 5x minus 2 equals 0. Here, x squared minus 5x minus 2 equals 0, so x squared minus 5x equals 2. Then x squared minus 5x plus negative 5 over 2 quantity squared equals 2 plus negative 5 over 2 quantity squared. So that's x squared minus 5x plus 25 over 4 equals 2 plus 25 over 4. Simplifying on the right, we get x squared minus 5x plus 25 over 4 equals 33 over 4. And then simplifying on the left, that's x minus 5 over 2 quantity squared equals 33 over 4. We take the square root of both sides to get x minus 5 over 2 is equal to plus or minus the square root of 33 fourths. So x equals 5 halves plus or minus the square root of 33 divided by 2. So x is either 5 halves plus the square root of 33 over 2, which is about 5.37, or x is 5 halves minus the square root of 33 over 2, which is about negative 0.37. Another example, solve 3x squared minus 3x minus 7 equals 0. Then 3x squared minus 3x equals 7. So x squared minus x equals 7/3. We've just divided everything by 3 there. X squared minus x plus 1/2 quantity squared is equal to 7/3 plus 1/2 quantity squared. That's x squared minus x plus 1/4 equals 7/3 plus 1/4. So x minus 1/2 squared equals 31/12. Then x minus 1/2 equals plus or minus the square root of 31/12. So x is equal to 1/2 plus or minus the square root of 93/6. Then x equals approximately 2.11 or approximately negative 1.11. A note on completing the square: the process of completing the square works to solve any quadratic equation, even if it can be solved by factoring or using the square root principle. It's generally easier to factor or use the square root principle. So if you use these processes instead, you are advised to, if you can use those processes instead, you are advised to do so. Examples are on page 620 and 621, but will not be replicated here. Another method for solving quadratic equations is to use the quadratic formula. This formula results from solving the standard quadratic equation ax squared plus bx plus c equals 0 by completing the square. In fact, we almost achieved the quadratic formula when showing the steps to complete the square. We only have simplified the resulting equation a little further. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are real number coefficients of a quadratic equation in the form ax squared plus bx plus c equals 0. A good mnemonic for the quadratic formula is that it can be sung to the tune of Pop Goes the Weasel. Last year I was teaching high school math, and I sang this every time it came up to drill it into my students' heads. I'm going to sing it once for you and never again. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. If you sing it a lot, you'll remember it. Solving with the quadratic formula. To solve quadratic equations using the quadratic formula, first write the equation in standard form. Identify the values of a, b, and c. Substitute numbers for a, b, and c in the quadratic equation. Use the order of operations to simplify the expression under the radical, then simplify the radical. Factor any common factors in the numerator, simplify by reducing, and write as two distinct solutions, and then write as exact solutions or approximate solution if as desired. So use this quadratic formula to solve x squared plus 5x plus 6 equals 0. In this equation, a equals 1, b equals 5, and c equals 6. So x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6 divided by 2 times 1. Which is negative 5 plus or minus the square root of 25 minus 24 all over 2, which equals negative 5 plus or minus the square root of 1 all over 2, which is negative 5 plus or minus 1 all over 2, which gives us negative 5 plus 1 over 2, or negative 5 minus 1 over 2. If x equals negative 5 plus 1 over 2, then x equals negative 4 halves, which is negative 2. If x equals negative 5 minus 1 over 2, then x equals negative 6 halves, which is negative 3. We can check these solutions. Negative 2 squared plus 5 times negative 2 plus 6 equals 4 minus 10 plus 6, which is 0. And negative 3 squared plus 5 times negative 3 plus 6 is 9 minus 15 plus 6, which is again 0. So both solutions check. Use the quadratic equation to solve the equation 3x squared minus 3x minus 7 equals 0. In this equation, a equals 3, b equals negative 3, and c equals negative 7. Then x equals 3 plus or minus the square root of negative 3 squared minus 4 times 3 times negative 7 over 2 times 3, which is 3 plus or minus the square root of 9 plus 84 over 6, which is plus or minus the square root of 93 over 6. We've already solved this equation using the method of completing the square, and the solutions we found here are the same. Even though quadratic equations have two roots, a root may be disregarded in an applied problem because it is not appropriate within the context of the problem. For example, suppose we want to find the length and width of a rectangular table if the length is 8 inches more than the width and the area is 260 inches squared. We can set up the equation 260 equals x plus 8 times x, where x is the width of the table, and solve it by any method we like, probably the quadratic formula, to find solutions of x equals 12.6 and x equals negative 20.6. However, we can't have a negative length, so it's inappropriate to give the solution x equals negative 20.6. For this problem, the width is 12.6 inches and the length is 20.6 inches, each rounded to 1 decimal place. 12.6 times 20.6 is equal to 259.56, which is close enough to 260 for our purposes.